All right, friends, today we're going to talk about solutions of inequalities. So we're going to continue what we started yesterday. And so we're going to be looking at inequalities and being able to graph them on a number line. So this one says unknowns on a number line. The number line shows several points, each labeled with a letter. And so I see that D looks like it's about 0, and then to the left of D would be negative numbers, and to the right of D would be positive numbers. So the first question asks us to fill in each blank with a letter so that the inequality statements are true. So something is greater than something else. So F is greater than E. That's true because F is further to the right than E. That's a true statement. For B, it says something is less than something else. So I could say A is less than B, and that also works. Other solutions for this, so there's other things that could work. So something greater, so D is greater than C. Let's see, B is less than C. You could say D is less than E. You could say that E is greater than D, right? So it goes, you can have multiple different options here. Randy says that she found 3 different ways to complete the first question correctly. Do you think this is possible? Explain your reasoning. Yes, Randy is correct because there are multiple solutions to the inequality statements. And I could say, and if I wanted to further go into that, I could say, D is greater than C. I could say E is greater than D, right? I have F is greater than E. I could say B is greater than A, right? That's at least 3 there, which is really 4, so there's more than 3, and that kind of covers your bases, right? And the last one says list a possible value for each letter on the number line based on its location. So I'm going to start with D. D, I believe, is 0, so that tells me if D is 0, numbers to the right of that have to be positive. So E looks like it's about 5. F, maybe 8. C looks like it is like negative, I would say -2. B to me looks almost equal distance to E, so I'm gonna maybe say -5, because that almost looks like the opposite of E. I'm sure some of you will say, yeah, maybe not, but to me it does. And then A looks like it's further out than F, so in that case, if that is that, then I'd say that maybe this is -10. And that solves this part, right? So it's basically looking at this and saying, which are the possible solutions for this? Kind of gets us in the right mindset for today's activity. So the next activity, we're going to be looking at amusement park rides. So it says Isa finds these height requirements for some of the rides at an amusement park. So the high bounce, you must be between 52 and 72 inches tall. The climathon must be under 60 inches tall. The twirler coaster, you need to be 58 inches minimum. So writing an inequality for 3 height requirements, use H for the unknown height, then represent each height requirement on the number line. So when it tells me that it needs to be between, for the high bounce, when it says between 55 and 72, what I think that it does not include those. So that's my first inclination, is to think it does not include 55 and 72, but they have to necessarily be between. So my inequality, I'm going to say that H has to be greater than 55, but then I'm also going to write over here H is less than 72. So H is between those numbers, and notice how I wrote that, right? So 72 is greater than H, and H is greater than 55. To graph this, remember that if H cannot be that value, what we're going to use is we're going to actually use a open circle or unshaded in circle. And for this problem, I'm going to start with 50 over here and then go to 55, then 60, 65, 70, 75. And I know those are pretty close together, so I'm going to space that out a little bit because I have the room to. So maybe 50, and then 55, and then 60, 65, 70, 75. Like, they just seem too cluttered for me, so that's why I rewrote it. So it has to be greater than 55, so I'm going to put an open circle around 55, right? Because it cannot include that. And then 72 is probably pretty close to, that's going to be 72 and a half. So somewhere around here, I'd make an open circle again. And then what I'm going to do is I'm just going to shade in a line, because you can be any height in between those to ride the ride. And that's what I'm going to do for that. The climathon says that you have to be under 60 inches. So that means that you cannot be 60 inches. You have to be less than that. So for this, I'm going to say H is less than 60. And for this one, again, I'm going to spread these out. So 50, 55, 60, 65, 70. So remember, it does not include 60, so I'm going to have an open circle, and I'm just going to draw an arrow indicating any number less than that. For the next one, the twirler coaster, you have to be 58 inches minimum. For this one, you have to really think about this. 58 inches minimum means that I can be 58 inches tall and still ride this ride. I just have to meet the minimum requirement, which is 58 inches tall. So H is greater than or equal to 58 would be my inequality statement for this one. And then I have 50, 55, 60, 65, 70. And for this one, I have to be greater than 58, so 58 is going to be somewhere around here. And we're looking at any value greater than that. So I'm going to shade in to indicate that it's any height greater than that. All right, and so that's how we do that part. So Pike's cousin is 55 inches tall. Pike doesn't think she is tall enough to ride the high bounce, but Neil believes she is tall enough. So we're going to look at 55 inches tall. Well, based off what we graphed, right, we said that H for high bounce, H has to be greater than 55. And if Pike's cousin is 55 inches tall, then I agree with Pike. She cannot ride the ride because she has to be at least taller than 55 inches. So I agree with Pike because she has to be at least 58. Oh, did I write that wrong? She has to be at least greater than 58 inches tall, or greater than 55 inches tall. Next part, right? So we're still working with the same thing. So it says Issa can ride the climathon. So I'm going to reference this page, climathon. But she cannot ride the high bounce or the twirler coaster. So she can ride one ride, but not the other two. What, if any, could be Issa's height? Be prepared to explain your reasoning. So to ride the climathon, you have to be under 60 inches tall. And so we plotted that here. So it cannot be 60 inches tall, but she cannot ride the other one. So we know that for this particular problem, for the high bounce, she has to be greater than 55 inches, and she could ride the high bounce. For the twirler coaster, she has to be greater than 58 or equal to 58, and so she cannot be 59 inches, because if she's 59 inches, then she can ride the high bounce, and that says she can't. If she's 56 inches, then she can also still ride the high bounce. So the only one where she can just ride one ride is 53 inches tall. Jet is 56 inches tall. Which rides can he go on? So if Jet is 56 inches tall, he could ride the high bounce. and the climathon. Dominic is 60 inches tall. Which rides can he ride? He can ride the high bounce and the twirlo coaster. The inequalities, h is less than 75 and h is greater than 64, represent the height restrictions in inches of another ride. Write 3 values that are solutions to both of these inequalities. Well, you could be 65 inches tall to ride that ride. You could also be 66 inches tall, be 67 inches tall, 68, 69, 70, because those numbers are greater than 64 but less than 75, and you can go all the way up to 74. I don't know if they can see that. That's my problem. All right. The next activity, you're going to get to play a little game, which number am I? I believe I have the cards. Yeah, I have the cards here. So you're going to be given a card set which says numbers in one. One baggie, you'll get numbers, and what we're going to do is shuffle those. In the other baggie, you're going to be given the inequality statements. So your job is to give people clues about the number that you have to see if they can guess it based off the inequalities you give them. So for this activity, you're going to shuffle your number cards. I'm going to try my best with these, right? Shuffle them. You're going to put them face down. And then for these, you can spread them out so that everybody can see them, right? Because you want people to be able to pick a correct inequality statement for this. So, for example, I have -4. So I'm looking for an inequality statement that would include, right, the value of -4. So, is -4 less than +6? Well, yeah, so I could use this one as a way to give someone a clue. Is -4 less than +1? Yes, it also is, so I could use this as well. And is -4 less than -3? Yes, that is. So if I was giving clues, and I know you can't see them, that might be part of the problem here, is my issue with sizing today. So these would be the 3 clues, right? So this number would not be displayed, so this would be just for the clue givers, and then the detective would get those things. So they have to pick a number. Like make 3 guesses as to which would fit that inequality statement. So for them, right, so you could say, 3 is less than 6, but is 3 less than 1? No, so it narrows it down. So you're looking for a number that's less than -3, but also less than 1, but also less than 6. Well, a number less than -3 could be -4, right? And that's the number that they drew. So as long as this solution is a solution for all possible ones, that's what you're looking for in this activity.